Parity of a function, odd function. Definition 3. Let f be a function defined on a domain D of f. We say that f is an odd function if and only if its domain D of f is centered at 0 and f of minus x equal minus f of x. So in order to say that the function is an odd function, we have two conditions. The first condition, its domain must be centered at 0. As we remember from before, the centered interval is an interval such that for every x belongs to D of f, minus x also belongs to D of f. This is the first condition. The second condition, f of minus x must be equal to minus f of x. Remarks, please pay attention to these remarks and listen carefully. A given function defined on a centered interval at 0 is not necessarily odd. Not every centered interval at 0 is an odd function. It may be odd or not. If d of f is not centered at 0, then definitely the function is not an odd function. So, in order to say that a function is an odd function, first of all we must check if the domain of definition is a centered interval or not. If a function f is not odd, does not mean that the function is an even function, and conversely, so we may have a function which is defined on a centered interval which is not even nor odd. Example 5. Given a function f defined on R by f of x equal x cubed. Prove that f is an odd function. Solution. First of all, we find the domain of definition, which is R, so d of f is centered at 0. Now we check if f of minus x equals to minus f of x. Here f of minus x equal minus x cubed, which is equal to minus x cubed, so equals to minus f of x. So f is an odd function. Example number 6. Given a function f defined on R by f of x equal x cubed minus 5. Is f an odd function? Justify. Solution. D of f equal R, which is a centered interval at 0. Now f of minus x equal minus x cubed minus 5, which is equal minus x cubed minus 5. Now we take minus as a common factor, so we get inside x cubed plus 5, which is not equal to minus f of x. So f of minus x is different from minus f of x. Then f is not an odd function. Also, if we check, f of minus x is not equal to f of x, so the function is not an odd function, neither an even function. This means that if the function is not an odd function, it is not necessary to be an even function. Application 4. Given a function f defined on negative 3, 3 by f of x equal 2x over x squared plus 1. Prove that f is an odd function. Please pause the video and try to do it by yourself. Solution. D of f equal minus 3, 3, which is centered at 0. Now f of minus x equal 2 times minus x over minus x squared plus 1 equal negative 2x over x squared plus 1. We put negative outside, we get minus f of x, so f is an odd function. Application number 5. Given a function f defined on negative 2, 5 by f of x equal x cubed minus x. Prove that f is not an odd function. Please pause the video and try it by yourself. Solution. D of f equal minus 2, 5, which is not a centered interval at 0. This means that f is not an odd function without even checking f of minus x if it is equal minus f of x or not. Also, if we note that f of minus x equals to minus f of x here in application 5, but since d of f is not centered, then f is not an odd function. Parity of a function, odd function. Property number 2. Let f be a given function defined on I such that f is an odd function. The curve C of f has the point O as a center of symmetry. This means that every point on the curve C, if we take its symmetry with respect to O, this point will be also on C. Please look at the following figure carefully. If we take any point on the curve C and make its symmetry with respect to O, the point which is symmetric to this point is also on the curve C. Here we take several particular points. Please look carefully on each point. Example number 7. Which of the following curves is the graphical representation of an odd function? Justify your answer. Please look at the first curve. Here we have every point that belongs to the curve. The symmetry of this point also belongs to this curve. If we look at the second curve, also we take any point that is on the curve and we make its symmetry with respect to O, the point symmetric to this point also belongs to this curve. So the first curve represents an odd function, also the second curve represents an odd function. Application 6. Which of the following curves is the graphical representation of an odd function? Justify your answer. Please pause the video and try to do it by yourself. Solution. The first curve is not the graphical representation of an odd function since it does not have the point O as a center of symmetry. We can take any counterexample and make the symmetry with respect to O to find that the symmetry does not belong to the curve. The second curve is the graphical representation of an odd function. If we look at the following figure of the second curve, every point on this curve has its symmetry with respect to O, so O is the center of symmetry. Assignment. Please review the following page from your textbook. Homework. Please do the following homework. Summary. Please read the summary carefully and take notes to your copybook. Thank you very much.